Welcome back to this series that we have designed to help you pass a high-stakes math test. Now this one is going to be about factors and multiples. Factors and multiples in themselves are not likely to be on a high-stakes test. They might be, but they are far more likely that you need to know factors and multiples and have easy access as a part of some other problems. So it's important that you understand how to quickly come up with and verify what numbers are factors or multiples of other numbers. And we've got a great joke for this one. You know what's odd? Every other number. So what is a factor? A factor is the numbers you can divide by and there's no remainder. So let's look at 24's factors. You can always start with 1 because 1 is a factor of every number. 24 is even, so we know 2 is a factor. 2 is a factor of all even numbers. You probably already knew that, but if you didn't, you need to know it, and you know it now. 3, I just happen to know 3 is a factor. 6, 4, 8, 12, and 24. All of those numbers can be divided into 24 and you won't have a remainder. And that's all of them, and I just happen to know it's all of them. But I will show you how to verify that you've got them all. Let me remind you what a prime number is. A prime number has only 2 factors, 1 and itself. You might even think of them as that they don't have any factors other than themselves, because of course 1 goes into everything. And so the only number other than 1 that you can divide a prime number by and not have a remainder is if you divide it by itself. So the prime numbers are essentially like the building blocks of all the other numbers. The other numbers can be broken down into their prime pieces. And the prime numbers are like the atoms that you can't break them down. Hopefully they wouldn't explode if you did. But prime numbers are a very important concept. And there's no pattern to the prime numbers. They just show up at random among the other numbers. And we know that there's infinitely many of them. You don't really need to know that. It's just an interesting fact. But you do need to know what a prime number is. Here's some examples of some small prime numbers. We don't include 1. The prime number has to be a positive whole number greater than 1. There are reasons for it, mathematical reasons that you will not be asked on a high-stakes test. So 2 is the only even prime. It's prime because there's nothing that it has no factors other than 1 and 2. It is the only even prime number because 2 is a factor of all other even numbers. So other than 2, all prime numbers are odd. So how do you know if a number is prime or not? You try dividing every number smaller than it into it, and if none of them go without a remainder, you've got a prime number. Now that's not a very reasonable thing. That's why you want to know how to tell what the factors of a number are so you know whether it's prime or not without having to do a million division problems to figure it out. When I listed the factors of 24 in the example, I just tried to think of them. And that's not a very good way to do things in math, to just try to think and hope you can do it. A method is much, much better. So I'm going to show you how to make a prime factor tree, and then we can get all of the factors of 24 from that tree. So we start, and this is even kind of fun, a lot more fun than just trying to think. So you start by, you draw the tree branches, just 2. You want to do this 2 at a time. And then think of any 2 numbers that multiply together to make 24. And since 24 is even, we could have used 2 because for sure 2 is a factor. But no matter what you use, as long as they are factors of 24, it's going to turn out the same in the end. So however you want to break it up is fine. I did 6 times 4 is 24. So that's my first step. Then you take each of those 2 numbers and you break them up one at a time into 2 of their factors, and you keep going until you have nothing but prime numbers at the bottom of the tree. Now, any and all numbers that we can make by multiplying together numbers at the bottom of this prime factor tree are factors of 24. So 3 times 2, 6. 2 times 2 times 2 is 8. 2 times 2 is 4. The 3 times 2 times 2 is 12. Even though you have to make sure that you don't miss any by overlooking something that you could have multiplied together, this is still far better than just trying to think. Getting started on a factor tree is sometimes easy and sometimes hard. You have to be able to think of the first step, which is what are two factors of this number. So here are some tricks that help you. Any number that is even, 2 is a factor. Most people know that. And 5 is a factor to any number that ends in 5 or 0. These next two are less commonly known, but very handy. If you add the digits of a number together and that is divisible by 3, then your original number is divisible by 3. And the same is true for 9. This only works for 3 and 9. But if you add the digits together and that is divisible by 9, then your original number is divisible by 9. We need to factor 51. 51 sort of looks prime. It's one of those, has that prime feel to it, but it's not prime, because if we add 5 plus 1, add the digits together, 5 plus 1 is 6, and 6 is divisible by 3, so 51 is divisible by 3. Once you know one of the factors, you can find the other one just by dividing. Divide 51 by 3, you get 17 with no remainder. And both of those numbers are prime, so you're done. If you have to factor 219, well, it's not even, 5 doesn't go in, but let's add the digits. 2 plus 1 is 3, 3 plus 9 is 12. 3 goes into 12, so 3 goes into this number. I can divide 3 into that in my head. It's 3 times 73. Let's say you need to find the common multiples of 24 and 36. And usually you're looking for the smallest common multiple, which they call the least common multiple, or LCM. And one of the ways that it's commonly taught is to just list all the multiples of 24 and then list all the multiples of 36 and keep listing them until you note that you've got a match. And that's very tedious and it's error prone. So I'm going to show you a way that's not quite as tedious and not quite as error prone. So factor both of the numbers down to their prime factors and then circle the ones that they have in common. They both have 2 2s and a 3. And then, so that right there is your greatest common factor, 2 2s and a 3. That is 2 times 2 times 3, which is 12. So 12 is their greatest common factor if you're asked. That's how you would find it easily. But to get their least common multiple, we need only one of the things that they have in common. So 2 times 3 times 3, and then we need whatever's left over to come into this number. So 2 times 2 times 3 times 2 times 3. That is 12 times 6, which is 72. So the least common multiple of these numbers is 72.